can happen. But I'm Andre, to introduce myself properly. I am a Python teacher and an Arduino teacher, and well, I get involved in the curriculum development team and other things around around the company here. And so I'm here to introduce you guys to this whole course we've got. Wanted to make sure everyone could hear me.
My dad's doing some kind of setup here.
All right. Sorry about that if you guys couldn't hear me before. Just one thing after another. But now that we're in, I'm excited to get started here. This is one of my favorite things to talk about here, is the whole Arduino course. So it looks like we might be having a few people coming in. But I guess I'll get started here, and I'm just going to go off and to begin. To begin, I'm going to just kind of be playing around here. I'm going to show you guys a basic circuit that's kind of fun here that I can make in a few minutes. And I'm going to just talk to you guys a little bit about what this whole Arduino thing is and what all we're going to be doing in the course. And so hopefully you guys can get an idea and see some fun stuff here. But I'm gonna get started here. Let me change up my camera a little bit, and I'm gonna start showing you guys something interesting here. Give me 1 second. Okay, so sorry about that, you guys. I was just trying to get this set up here just so we could take a look. I wanted to be able to show you guys a little bit about you know, how we're really going to go about this in the course. Now, we're going to use a few different things to go through this course, and you know, we're going to be doing a couple different kinds of designing, a couple different kinds of things. We're going to be getting into a little bit of programming, and we're going to get into a little bit of circuit design, and we're going to do that in one of two ways in the course. One, we're actually going to use these things here, and this is called a breadboard, and this is actually a lot simpler than it looks. All this is just something that's well, it's got metal in here, and so it just lets me place little components in here and just kind of stick them right in there. So it's got a whole bunch of holes. And so it might be kind of hard for you guys to see. I'll show you another example. We can take a look at some other examples online, and I'll show you some maybe things that'll be a little easier for you to check out. But whole point of a breadboard is that, again, I can just place little components. I can take, you know, buttons and switches and other things and motors and batteries and just plug them right in here. And so then it allows me to really easily and quickly build up some circuits, and I get to, you know, play around with electricity really fairly quickly in that way. So one thing that I could show you guys that's kind of fun, I did this last week for the demo, and I think it really showed just some basic things that we can do with electronics and other things, and how quickly you can put something together that can just, well, it can be a heck of a lot of fun, if anything. And so I just wanted to show you a couple things here. I've got all these parts. I've got, you can see here, I've got a wire, and I've got something interesting here. And this tiny little piece here is really interesting. And, we'll learn more about what these are, but this is called an integrated circuit. You can basically imagine is that they've taken a whole bunch of components and put it all into one tiny little chip. And then that allows us to do some really interesting things. You see these all over in computers and everything. The whole world is made of these little integrated circuits nowadays. And you guys don't have to worry too much about what all is going on here, what all the parts are, but I'm just going to quickly build something that'll show you some of the fun that we can have with electricity and with electronics. And so I'm going to take a couple things here. I've got a speaker, and I pulled this out of well, I can't actually remember, honestly. I think it might have been to some kind of gaming chair, or maybe to like a remote control car or something. You can find all kinds of little parts and whatever else. You guys will eventually get into that, I'm sure. You can find all kinds of things on, in old toys and whatever else, and pull them apart and put yourself together a nice scrap box, and well, you can make some fun stuff with it. So I've got a little speaker here, and then, like I said, I got this integrated circuit, and then you can see this thing right here. This is called a capacitor. And so these are really interesting little things. They're almost like tiny little batteries. They hold a little bit of power, and we'll get into more of what all we can do with them, but they're real fun, they're real useful, and they're pretty easy to use overall. Like we said, we can just stick it right into the breadboard there. Got to connect a couple other wires together. I don't know how much you guys know about electricity, but electricity is a really interesting thing. It's it's a naturally occurring thing in our world, and it's something we're still learning a lot about. And it's why it is that it's a really cool thing to get involved in learning about, because it means that so much of the things that you do are totally original. They're you're learning about new areas of science. But most basic thing to understand about electricity is that electricity flows in a big circle. If you take a look at here, we've got an actual battery. This is just a 9-volt battery. There is, on this, we have two sides. We've got the big one here is the negative side, and then this smaller one here is the power side. And the reason the power one is usually smaller is that way it's harder for us to accidentally bump into. That makes it a little safer to use. But any battery that you find, it's all going to flow the same way. Power flows out of the smaller one, and it flows into the big one. And then, so if we were to take a light bulb or a motor or something else and put it in between there, well, then we could power up the bulb. And so we'll show a little bit about that. But it works the same way here. I can connect this battery up to my thing here, and I could take the positive and negative, and I'm going to mark the positive with a red wire so we can show that that's where the power is coming out of, and then we're going to mark the negative with a black wire so we can see that that's where that's where the power is flowing back in to the battery. And so then I can just put a couple more parts in here before we get started, before I jump ahead. I'm going to put one more thing in here. Or maybe I'll leave this one out for now. We'll show actually what that does. But like I said before, you guys don't have to worry too much about what all is going on here. Just wanted to give you the demo. And so I'll have to try this here. Give me a second and we'll see if this this is working yet. I'm gonna grab one more part here. Give me a second. So then this last part that I've got here is a little input jack. So now I can plug something into this circuit and you guys get to see what it actually does. Granted that I've done everything correctly, we'll have to make sure it actually works. That's the good thing about a breadboard though, is that you know, we can come in here and we're able to quickly and easily build circuits, and if we make a mistake, well, we can take it apart and we can easily fix it or whatever we need to do. Now let's see if I can get this thing working. Well, like I said, you guys, this will only take a moment, and then we're going to move forward. And I'm actually going to talk to you a little bit more, because what this circuit here does is, well, it allows us to take in some audio and amplify it. And in just a moment here, you'll be able to hear that. Give me 1 second. Well, you know, this happens from time to time, you guys, that you put something together and it doesn't seem like it's quite working right. And usually it's a much, much simpler error than you can imagine. And that's always why it's a good idea to have notes on you. So this is something else that we'll be doing. We'll be getting into this. And one of the things that I always recommend for everybody is that you keep a notebook and that you always have lots and lots of designs and ideas. And so here we go. I can actually see, this is something else we'll talk about. You guys kind of see my circuit design here. And so this is actually the circuit I'm trying to build. And once again, you guys, right now, you might look at this and it just looks kind of like a whole bunch of jargon. It's hard to make much sense out of, but I'll tell you right away. Here, maybe it helps if I go like that. I'll tell you right away, though, that something like this is a way simpler than it looks like. There's only a couple of wires here, and there's a couple symbols that we don't know, but these are all things we're going to be talking about. And so you guys,
I know some of those symbols.
Oh, really? So that's pretty cool. Yeah, you might know like some of these, like the ground or the positive and negative. Yeah, that's your basic.
I have snap circuits at home.
Oh wow! So you're a pro. So let's just try and figure out here what exactly is my error. So we can see that in order to use this thing, I want to plug my audio input into line 3, and I'm doing that. And then I want to go to ground. Then I want to connect my pins 1 and 8 together. And then I want to send ground there. And I want to send power there. Last thing I'm thinking, who knows, maybe my battery's dead. That happens from time to time.
Pretty much.
Well, like I said, though, I just wanted to quickly show you guys this, though I don't want to spend all day on it if it's going to give me problems. 3. I'm going to try a different battery and a different connector here. see if that helps us out a little bit. But like we said, we'll move on because there's some other projects. And actually, I've even been working on a little project that really uses the Arduinos. I've been working on a little robot that I want to get around to showing you guys in a little bit here. So I've got some pretty cool stuff to show you today, but I really wanted to get this working. But if anything, I think what this can show you guys is some of the process we'll be going through. Obviously, for us, one of the things that we'll be doing is we'll be going online, and we'll be developing our circuits online first, because as you can see, you know, when you're starting to get into developing circuits, it sure can be a lot of fun, but there can be a lot of errors that can come up. And especially, although we're not working with any dangerous amounts of electricity, what can happen is that we can burn out electronic parts, and that really is too bad when that happens. You know, these parts, we got to buy them, and so it's nice when they last us as long as possible. You know, you guys, it might just be evading me today. I just can't seem to get this one. Like I said, there's always something or other. I apologize for this, though. It was my lack of preparation for the course. I was a minute late, and I didn't have everything laid out in front of me. And so it seems that I'm going to just be wasting time. What do you say?
15 minutes late.
Yes, I do apologize for that one. But we'll come back to this, and maybe we'll figure this one out at the end of class. But like we said, we don't want to waste too much time. What this all was supposed to do is that this is, and like we said, I think it really is, my battery might just be dead, and that's too bad. But what this did was that this allows me to plug in my electric guitar here and actually play right into this amplifier. And so, you know, like we said, we'll come back to that, and maybe we can get it functioning later. But you know, all the time, these amplifiers, they're very, very useful for us. You know, we use them in speakers, we use them in microphones, we use them in you know, they're all over our computers. And even that's what's cool about this circuit right here, is this little tiny chip here that I showed you guys, this black piece. I realize that my camera's not in the right spot. This little tiny chip here, I'm going to pull this out so we can look at it again. This thing is in your guys' computers, is in your, most likely some kind of version of it in your phones. It's a very, very common chip. And like we said, you know, you guys don't have to worry too much about how all this circuit works here right now. But if anything, you know, that's a big part of what our class is going to be about, is we're going to be learning about all of these things in our world that are incredibly common, you know, circuits and designs and components that you know, we're constantly using, that we might not really know much about. And we're going to learn more about how they really work and how we can use them. And we're going to get into all of that. And a big thing that we're going to be using to do that is the Arduino chips. And so I want to get into that. We're going to push this aside, and we're going to talk about Arduinos. So I'm going to put this one down right here. So this here, you can see it's pretty small. This is an Arduino Uno. And so I don't know if you guys have seen one of these before, but these are pretty darn cool. You said that you got, you've got like the kind of connectable circuits and other things. And so, that's what's cool about the Arduino. It's kind of this whole plug and play deal. We've got pins we can plug right into, and we can connect to different things. We can jump right over to our breadboard, and we can connect up to there, and we can create all kinds of fancy circuits. You can create anything with an Arduino. You can go from as simple as controlling a single LED to, well, something much more complex. And I can even show you one project that I've been working on today. This is one of my robots that I've made with Arduino. And I've actually just started working on this one in the last couple of days. So all I've got for now is a basic walking algorithm. So I could show you guys what that looks like. And so you can see I'm not using my hands here. And right now he's going kind of slow because I haven't tested it, but I'm imagining that I can set the program to go much faster. And so then he can move around too. And currently he's just walking forwards, but you can see, you can see how it works is that he kind of turns his feet and then he twists to the side. And so it's pretty fun stuff. You can actually take a look at him too. And he's got on the front of him, this is called an ultrasonic sensor. And we are actually, you guys are going to get one of these. If you choose to take the class, you'll order a kit that'll come with one of these, and we'll learn all about how they work. They're actually really easy to use. What the ultrasonic sensor does is you see that one of these things acts like a speaker, and the other one kind of acts like a microphone. And so they send out a sound wave. And then you could imagine that sound wave is going to go forward and it's going to bounce off of a nearby object. And then it'll come back and it'll be read by this microphone here. And then, so through that, we're able to then determine, based on the speed of sound, we can determine how long it took that sound wave to return to the robot. And we can actually determine how far away the object is. Now that sounds like a lot. Say again?
It's echolocation.
Basically, yeah, this thing's gonna see like a bat. It's pretty cool. And you'd be surprised, that's actually thanks to the Arduinos and all of these really advanced parts that we're going to be checking out. It's super easy to do. We can open up the free Arduino software and we can write a couple lines of code, and we'd be able to determine if there was an object in front of our robot, and not only if there was, but exactly how far it was away, down to the centimeter. So we can be really exact. So it's pretty cool stuff. And then you can see I have this one down here, and this is actually a laser sensor. And so this sends a really specific beam down. And that way, if he's like walking on the table and he starts moving and now there's no ground in front of him anymore, now he can detect that, oh, he's about to fall off the table, and then so he'll start moving backwards. And so there's all kinds of sensors we can put into these things, and we're going to learn how to use the ultrasonic sensors, and we're going to learn about a few other kinds too. So obviously that's a big part of making any robot, really. Until you add sensors and AI and other things, any robot is just kind of a machine. It's just a static, it's basically just a toy walking around. But once we add these sensors and the AI, then it actually begins to perceive its environment, and it becomes a robot. So that's the difference between machines and robots, just for you guys' information. And so this is kind of just a machine at this point, but soon enough, it's going to have the sensors worked in. I actually just wrote that walking program that you guys saw there today. I've only been building this robot for 3 days too. I'll say that to you guys. I've been working on robots and things for a while, but this particular one I actually just started a couple days ago, and so I've already got it walking. So it takes some time, it takes some understanding, but it's a heck of a lot of fun, I can tell you that. And we're going to learn about the basics of it in this class. We're going to learn about using these sensors. We're going to learn about controlling motors and you guys are going to find it's a lot easier than you might think. And I can even show you a little bit of it too. Here, I'm going to share my screen with you. Got to find the right tab. There we go. So yes, I just wanted to quickly give you guys a feel for what all is going to be involved in our course here. So as we said, this is the Arduino course, and in this course here, I'm also going to move my camera back up here for now till we're ready. So the first question that I obviously would ask, and you know, I'm sure you guys might be asking, unless you already know, is, you know, what is the Arduino? And so I guess I'm curious, do you guys have an idea about what the Arduino is? Or you guys know about these things?
Nope.
Cool. Totally new. All right. Yeah. Yeah, I didn't know a whole lot about these, you know, when I first started working with them. You know, it was this totally new thing that had been introduced to me, and it was a really interesting concept. You know, I had always wondered about how they make robots, how they make machines, how they work all these really complex things that we see. You know, how can an autonomous car function really? Obviously, we know it's computers. Obviously, we know there's motors and there's sensors, you know, clearly. But how does it really work? It's a difficult question. It's a difficult thing to really fully understand. But Arduino is the basis for it all, you know, or at least things like Arduino is where you get started with it. Arduino specifically is a company, and Arduino, the company, makes microcontrollers, and you know, they make ones kind of like we see here on the screen, these ones. But you know, again, this is the Arduino Uno. You can see about how big it is. It just fits in my hand. And so that's why it's called a microcontroller, because it's fairly small, and because it's not really a machine or anything itself. It's a brain. It's a controller. It's used to control things as simply as possible. And again, I mean, when we say that Arduinos can be used for anything, I mean, really just about anything. You know, people utilize Arduinos for all kinds of things. They do have some limits, but certainly they, you know, they have their days. I mean, the Arduinos, as we saw, can be utilized to create robots and create different circuits. We didn't use one in the audio amplifier there, but you certainly could, you know, if you wanted to create some kind of electronic amp that had different settings and other things. People do lots of stuff like that. But more often than not, you know, again, they're used for robotics and in machines too. People do a lot of like hobbyist machines. People make machines that are capable of like writing things, or actually machines that are capable of creating things or drawing things. People make some really interesting things with the Arduino. People make their own 3D printers with the Arduino. You know, there's kind of just endless possibilities with it. It simply is something that allows you to control electronics with programming. It's endless as your imagination. So it's pretty cool. And two, you know, the software is totally free to use. And as we said, it's actually, you know, there's things to learn, but there's aspects to it which you could say are a heck of a lot easier than you might think. You know, when you think about what it takes to make a robot, or to make a, you know, something, you know, some actual like artificially intelligent machinery, The basics of it are, well, they're fairly basic. So you can see, there's lots and lots of different kinds of microcontrollers out there. Big difference between a microcontroller and a computer is that these microcontrollers just aren't as powerful. They're not as fast. One thing you wouldn't be able to do with this, like you wouldn't really be able to load like like a video stream on an Arduino. Like they don't have that much memory or power. They can only run one program at a time. But at that, they could still do a lot with that one program. But that's the big difference between, regular microcontrollers and actual computers. And there are computers that are like really small that kind of classify as microcontrollers. I can show you like this. This is a Raspberry Pi. This is actually a computer. Okay, so you can see the difference between the Arduino Uno. It's a little bit smaller. This is a computer, this is a microcontroller. And this one you could actually, like, I could plug in, it has USB ports. I could plug in like a mouse and a keyboard directly to this and like play games and use this as a computer. So kind of interesting. But again, that's the general difference. Microcontrollers are a lot easier to use. So quickly here, I wanted to just show you guys an example of some of the things that other people have made with microcontrollers and then with Arduino. This is one here. This is one that I'll show you guys here just because it's incredibly cool, super advanced. And you guys may or may not have seen this on YouTube. This guy actually, and I mean, this is not a static program. This is a, it's got all kinds of sensors in it. And this is a robot that this guy built that is actually capable of pedaling and steering a bike. Pretty wild. And so, you can just imagine the amount of code that goes into it. And he went and talked all about it. This guy, he's very well-known scientist, very successful. But he goes into talking about it. He actually had to make his own brain for this thing. He had to make a brain that was going to work fast enough and be powerful enough to do to ride a bike. So it takes quite a bit sometimes. But just an example of what really is possible. I mean, again, there's no end to what can be done with microcontrollers and with Arduino. There's one example. Here's a fun one. Here's I showed you guys my bot, but here's another common one that people make. That's a pretty cool design. And so you can see they've actually got, it's like a crab almost. And people make these with 6 legs, with 8 legs, all kinds of stuff. I've seen them too, where they'll make them with legs and they'll have wheels on them. So then, they can be like walking around, or then they can drop down and they can wheel around, and people do some cool stuff. But, once again, you see they've got those ultrasonic sensors on them so that they're able to do object detection and avoid objects. But, overall, pretty cool stuff. Once again, just another example of what's possible with Arduino. But I know these are just robots. Again, I mean, people make all kinds of stuff with Arduino. They go from anywhere from machines to other things. I wanted to quickly show you, there was another example. I could show you guys here. Just got to find the remote control real quick. There it is. So this right here is a remote control that I made, and you can see it's got an Arduino on it, and this is an Arduino Nano. And this is actually a lot simpler than it looks, because this is a radio part you can buy online, and this is just a switch and a button. And so this was a really easy thing to make. And the reason that I made this was because that I was really, really tired of having to get up at night to turn my fan on. I think I plugged in the wrong thing. And so you can see here, I think I'm getting some interference because some things that are going on here. But anyways, I made a remote control for my fan so that I'm able to, isn't that funny? Usually it works from across the room fine, but right next to it, it doesn't. There, if I hold it over here, now it's working fine. So radio interference is a thing to learn about too. They don't always work the greatest, these cheap radio devices, but it does work when I need it to, you can see. And so that was something I made during the summer because I was so tired of having to get up at night to either go turn on my fan or to turn it off. And so I just made a remote control that allows me to control that. And then in order to do that, I actually had to make something, and so you can see now I've got an antenna sticking out of my fan too. And so I had to make something to stick in there and control the circuit. And so we'll talk a little bit about that, how that works too. You know, that uses something called a relay, and a relay is basically like a little automatically controlled circuit that, well, it essentially it can just be activated. You can use like 5 volts to control a whole lot more current, and that way you can use an Arduino to control a light switch or something else. And so it's pretty cool. I see we got some messages in the chat. Oh, show us the switches on the controller. Yeah. So really, really simple switches on the controller. There is an on-off switch, and the way that works is pretty simple. You know, when you can see that there's 3 pins there. So when it's when it's sitting like this, you see that those 2 pins are tied together. Now when it's sitting like this, then these 2 pins are tied together. And so you can see that's off and this is on. And then this button here just allows me to turn the fan on and off. And you guys, yep, you can see that. And then it goes off. And so pressing the button. And so that was a pretty simple thing to make. Like I said, you know, I mean, I won't try to explain exactly how it works, but that is something we also are actually going to be doing in this course. We're going to be learning how to make remote control. We're actually going to be using a better one than this, though. We're going to be using one that comes with a kit that we can get offline, and it's called an infrared remote. And so actually I want to show you guys that because that'll be cool. Give me 1 second here. So one of the things that that you guys will need for this class, you won't need it right away. You know, we'll be able to come in and we'll be able to do plenty of coding and learning about the basics of electricity and all other kinds of things like that. But then we'll need to get one of these kits. And now this is a really cool kit, you guys, because it comes with all kinds of stuff that we're going to use all through this class, and then stuff that'll be useful for you guys too afterwards. This will be good. We have 2 levels of the Arduino course, I should say that, and this will cover you for both levels. And so you're going to get your Arduino Uno. You see it doesn't actually say Arduino on it, but I can guarantee you it'll work all the same. And so then it comes with some essential components. We get a bunch of buttons and some sensors. We get a knob, and then that blue box there, this one right here, that is actually a relay. That's what I was telling you about. And then you can see we got a bunch of LEDs, and these are called resistors, the ones on the top left, and those are for reducing the current or reducing the voltage. But then you can see here's the remote that comes with the kit. And so we're going to learn how to actually program this remote, and we're going to use this remote to control different things. And so we can make LED strips, or we can make different electronic devices. and we can use our remote to control them. And so we're going to get into all that too in this class, and have a lot of fun with it. Like we said, there's a few different kinds of sensors that will be available for us to work with. This one, the one that says keys there, that's the one for the remote. That'll be the remote receiver. And then this thing below it, that's actually a joystick. And so we'll check that out. This blue one over here with the 3 pins sticking off it, that is a temperature and humidity sensor. So we'll show how we can actually keep track of the temperature and the humidity. We can make our own little digital thermometer. And that's pretty useful. The kit also comes with a couple kinds of motors. You see this blue motor that is wrapped up there. That's actually the same kind of motors that I have in my robot. So, you know, we're going to learn how we can control those and how those work. Those are really cool, really easy to use, actually. They're called servos, and they allow you to set a motor to a specific position. And that's a really, really cool, really useful thing, especially if you're trying to make a robot. You know, that's what you need to do. You need to be able to set the joint to specific places. And so that's what servos are for. Again, super easy to use with the Arduinos. You can see we're going to get a couple different displays that come in this kit. You can see this one in the center of the screen here that looks kind of like a clock. That's basically what it is. And so we're going to learn how to use those displays, and then a few other things. And you can see also it comes with an ultrasonic sensor. So all kinds of really, really cool stuff in here, you guys. And we're gonna go over all of it. And we've got again, we've got 2 levels in this course. In the first level, we're gonna go over things like, you know, just the basics of electronics and the basics of using the you know, the Arduinos. You can see here, this is the course layout. First one. First, we talk about the intro, and we talk about Ohm's law, and again, basic principles of electronics. And we'll introduce you guys to all these different electronic components, you know, the switches and the capacitors and the resistors and the transistors and all of the above. And then we'll get into some actual Arduino programming. And then we'll make a final project, which again, could be a number of things. You know, at that point in the course, we'll take a look at where you guys are at, and, you know, we'll think about things we want to do. We'll take a look at our kits, and we'll come up with an idea. And then the process that we're going to go through in this course is we're going to start by coming up with an idea, and then we're going to go and we're going to use this software you see mentioned here called TinkerCAD. And I'm going to open that up so you guys can see what that looks like. And so if we come to tinkercad.com, this is, again, totally free software we can use, and you can just hook it up to your Google account. And I can come in here to where it says circuits, and I can create all kinds of different things. And so you can see I've already got, I'll just pull this one up, that this was from our last demo. And so we'll kind of just take a look at how this stuff works. And this is a really cool thing. If you guys are interested at this point at all at just kind of learning more about how electricity works, I would recommend you come and check this out, TinkerCAD. I use this really to actually design circuits because it allows you to play around with things. And, you know, I mean, in real life, you could play around with the components and accidentally fry components, and, you know, and have a much more difficult time really understanding what's going on. But in a software like this, we actually get to take different things apart and very easily get to see what's really happening. Do you have a question, Adam?
I think I used this, like the 3D printing thing of TinkerCAD at school. So
that's sweet. Yeah, that's pretty exciting. You guys get to play around with 3D printers and things now at school. We had 3D printers when I was in school, but it was just beginning. They didn't really let us touch them. Yeah, so there's all kinds of 3D modeling software out there that's good. The CAD software is huge. It's used for 3D modeling. It's used for engineering purposes, you know, for actually just like engineers use it to design things like planes and rockets and robots. machines and all kinds of stuff. So yeah, I mean, using these 3D softwares it's not only good for knowing the Arduino, but yes, it can be good for, you know, actually creating things, and it's pretty important stuff. So it's cool that we get to use it here as well. And this again is a really cool extension of it, made specifically for working with microcontrollers and doing electronics and stuff. And so we can see here, we can do all kinds of things. We can actually simulate this circuit, and you can see that I can click this button and we can make the LED come on, and we can do all kinds of stuff like that. There's a few more things we could do. But you know, point is that we're going to go through, and if you guys are curious at all this circuit really is, it's just an LED and a battery. And I was just simply showing you guys again how electricity flows from one point to another. It just flows from the positive end into your electronics, and then out, and then back into the negative end. And I think a good way to think about this is, again, that electricity always flows back to the source. Electricity is kind of, we can almost think about it like water in ways, you know. Electricity flows through wire, kind of similar to how we think of how water flows through a pipe. You know, we're able to control different aspects of it. You know, the size of the pipe is obviously going to allow for more water to flow through, just as, you know, having larger wires makes allows us to transport more energy, and you know, things like that. We can also think about, you know, how water always wants to flow downhill. Well, electricity always wants to flow back to the source. So it's going to come out of the positive end, and this is where we have the fully charged electricity. This is totally charged electrons, and they're going to flow into this LED, and the LED will then use up the current, use up the energy in those electrons, and then all that energy, those uncharged electrons, then flow back into the battery. So that's important, you know. That's why we call it a circuit. That's why it's an electrical circuit, because it starts and it ends essentially in the same place. But that's the difference between a functioning circuit and a short circuit, is if we were to just directly attach the power and the ground together, then what that creates is, as we said, that creates a short circuit. And it's called that because it's a very short circuit. It's going directly from one point to the other. And the problem with this is, when we do this, then all that power, you know, we said this is where the charged power actually comes out of. And so if we just have that power now flow directly back into the battery, what this ends up doing is it creates a cycle, and the energy flows directly from positive to negative without ever getting used up, and it just keeps on flowing in that cycle as fast as possible, and it starts to get very, very hot very fast. And so, you know, if I were to take this battery in front of me and just hold down a piece of metal over the positive and negative here, that's what would happen. This battery would start to get really hot, and until eventually it just burnt out. So it's an important thing to understand, because, you know, that's how fires can get started with electricity. Generally, that happens when we're working with more electricity. Like we said, you know, a little battery like this might give off a little poof of smoke, but it's not going to be anything incredibly dangerous. But it is important for us to understand so that we don't fry all of our electronics. So bottom line is, electricity flows from power to ground, from positive to negative, from voltage back to source. It always wants to flow back to source. And so, you know, that again, that's why it's called a circuit. And that's why it is then we can very easily just take a wire, connect it here, and then take a wire and connect it here. And then you can see how right now you can kind of think of this as like this gray thing here is like a piece of metal. When it's on this side, you can see it connects those two pins together, but when it's on this side, it's connecting those two together. So here we have a completed circuit. We have the light on. Here the circuit is broken. There's no way for the electricity to flow, so we have no light. That's the basics of it all, you guys. That's the basics of working with electricity. And you know, as we said, from here, the step next would be to add an Arduino. So now we can use the Arduino to turn on and off the LED, or to control the brightness, or to you know, maybe to read from a sensor and then use the LED to express what the sensor is reading. Or there's infinite amounts of things we can do, and it's a lot of fun. I can tell you. Bottom line, it's all tons of fun. It's addicting, you know, getting into the robotics. You'll find yourself staying up night after night building little robots and whatnot. So I really encourage you guys to check out the course. Again, you know, there's the materials for it come out to about $50, and that's for both levels. And so that's, you know, 6 months of learning about robotics and electricity. And that, again, you know, that will be an intro to you guys for you know, for the whole world of electronics. If you want to get into robotics and engineering and just that whole side of technology, it's such a new area. You know, there's nobody who can really tell you exactly how to do it. The only way for you to really get involved is to just get out there and start doing it. But the people that know best are saying Arduino is where you want to start. So I really recommend you guys check out the course. One last thing I just wanted to show you before we end was just simply the Arduino IDE. This is totally free software that we can use with Arduino, and you can see it's as easy as I can make a new sketch, and it opens it up, and it even loads up the setup code for me, so I don't have to worry too much about how exactly all this works. I just, you know, I can define some variables right here, and we can write code that we want to loop right here. And again, you know, there's just a little bit of learning, but it's really, overall, it's pretty easy. And the code that we're going to be using, or that we're going to be doing in this course, you know, it's going to be very well guided. It's going to give you guys a chance to learn about C++ and other things, but again, you know, at a really gradual way. Like, we're going to work up to it very, very slowly, and so the coding will all make lots of good sense to you guys. And I can even show you some of the programs that we'll write in the course before you go, just so you can, again, get an idea of kind of the level of complexity that we'll be experiencing in the course. And so one thing here, just before we go, I'm just going to come over here to the Arduino programming, and just to quickly show you guys, I'll actually do this one. We'll do the sensors, and then I'll show you so. And again, you know, even in this program here, you can see that, like, this whole code here, this whole program here is even more than we actually need. Most of this that you're seeing here is actually just for printing out the temperature and the humidity and whether it's Fahrenheit or Celsius. But really, we'd only need a couple lines here, and this allows us to read from that. We were talking about the temperature humidity sensor, and so this is a code we'll write. And again, this is just a couple lines, and a lot of this we don't even need. We'll remove most of these lines here, and so the whole code for reading the sensor is just a few lines. And you know, same thing too here. I can show you guys for the say there's another temperature sensor, but we could keep going on all of that. I don't want to spoil too much for you guys, but point being is that we're going to get into it. We're going to do design first. We're going to come up with a working design in TinkerCAD. We're going to build the electronics, and then we're going to program it. And we're going to walk through each part of it together. We're going to give you guys a really, really good introduction to working with Arduinos, working with microcontrollers, motors, all kinds of different things. So again, I really encourage you guys to check it out.
See, check it out.
I'm going to share the class link with you guys so that you are actually able to sign up for the class if you like. Give me 1 second here to find that link. So I'm posting this link in the chat now for everybody to see. So I encourage you guys all to go copy this link, whether or not you are certain you want to take the class, go get the link so that you know where to go and sign up.
Thank you, Andrew. So we have one question. So my son Brian only has a programming experience with Scratch. Can he enroll this class?
Oh yeah, you know, and that's kind of the point that I was making, was that the programming that we're going to be doing in this course is now obviously having some experience would be beneficial, but really we're not going to be making a video game or doing any kind of incredibly complex code. So much of the code we're going to be doing has to do with specifically working with the circuit or the circuits that we're building. And so in that way, it's going to give a great introduction to C++ without really demanding too much. So no, I don't think you'll have to worry about any major programming experience. If you have an interest in electronics and you want to learn, it's a great course to get started.
Cool. Thank you very much.
Yeah. Little bits. And I guess I wanted to say that, Adam, I missed your question there. Little bits, I don't have a lot of experience with, but there are many, many microcontrollers out there. And you guys will find that, whether you're in, different programming languages, you're working with different softwares, so much of these things are all built around the same kind of idea. So if you use one of them, working with another one is generally pretty easy. So again, I encourage you guys to take a look at that sign up link and go sign up for one of the classes. We've got a few different times available. And again, I mean, if you have any interest at all in robotics and programming and engineering, this is the course for you. So I encourage you guys to join in. But if there's any other questions, please throw them out there. Otherwise, I think that's all I have for today. I hope you guys liked my robot. Can't wait to keep working on this thing. What I'm going to add to it next is, I said, I've got to finish up the walking algorithm and add some more sensors to it. So you guys will have to take the course and check out my progress on it. Anyways. That was pretty funny. Oh man.
Why does he keep falling? It's weird.
Because he needs one of these things. This is the gyroscope module. This is how he'll learn how to keep his balance. He doesn't have it yet. It's over here. There's lots to learn, you guys. But again, I encourage you to take the course and we'll get into it all. So I hope you guys enjoyed it. And again, I hope you have a good one. I hope to see you around.
Bye.
Have a good night.